In the second video of 4.4, we're going to look at special cases of factoring. Specifically, we're going to look at factoring when our a value is greater than 1, and we're also going to focus on a difference between two squares. First, let's look at an example of factoring when a value is greater than 1. Here I have the equation f of x equals 3x squared minus x minus 2. Currently I'm in standard form, and I want to get this to factored form. So similarly to how we did the ones where the leading coefficient was 1, I'm going to do the AC method. So I want two numbers that multiply to give me my A times my C value and add up to give me my B value. In this equation, my A value is 3, my B value is negative 1, and my C value is negative 2. So here, I'm going to want two numbers that multiply to give me 3 times negative 2, which would be negative 6. And I want those two numbers that multiply to give me negative 6 to add up to give me negative 1. So from here, I'm going to think about factors of negative 6. Since it's negative, I need one number to be positive, one to be negative. So those options are 1 and negative 6, negative 1 and 6, 2 and negative 3, negative 2 and 3. All of those options, if I multiply those two numbers to get together, would give me negative 6. But here, I could see that 2 times negative 3, if I add those numbers together, 2 plus negative 3 will also give me negative 1. So those are the factors that I want to choose. So here's what I'm going to do now. I'm going to write out my factored form of the equation, and I'm going to say x plus 2, x minus 3. In class, we went through a grouping method, which you can still do that. Here, I'm going to show you another shortcut where we can take the leading coefficient and save ourselves a step here. So what I'm going to do from this step is I'm going to take this leading coefficient of 3 and I'm going to divide it by both of my factors. So I'm going to do this, and I'm also going to do this. Now, 2/3 isn't going to divide to give me a whole number. So what I'm going to do in this case is I'm going to put that 3 in front of my x value. And I'm going to leave it like that. On the other hand, 3 over 3 will give me 1, so I'm going to change my factor to say this. And that is going to be my final answer. I like this method a little bit better because if I was to graph this in my graphing calculator, I would get zeros at negative 2/3 and at 1. And I think that sometimes dividing by that leading coefficient, it might be a little bit easier to see that rather than seeing like 3x plus 2 and having to interpret from there. Next thing we're going to talk about is perfect square trinomials. A perfect square trinomial is a trinomial that is the square of a binomial. What that looks like as an example is this. X squared plus 10x plus 25 is a trinomial because we have 3 terms. But it could be simplified to just say x plus 5 squared. X plus 5 is a binomial. If I square it, it would give me x squared plus 10x plus 25. There are some rules that go along with these. You can just FOIL these to kind of get back and forth between like standard or factored mode, but I think it's kind of good to go over them. So here are your 2 rules for perfect square trinomials when you're adding the 2 terms or when you're subtracting them. An example of a perfect square trinomial, let's look at the one we had before, x plus 5 squared. Now what I could do with this is I could FOIL it. X plus 5 squared is I'm just going to multiply x plus 5 by itself twice. And when I want to FOIL this, I'm going to do my first terms, outer term, inner term, and my last term. That is going to simplify to give me x squared plus 5x plus 5x plus 25. Finally, this is going to simplify in the middle when I combine like terms. Give me this, x squared plus 10x plus 25. what this is basically saying, or what that top equation is saying, is that if I make my a value x and my b value 5, I don't have to necessarily go through all the FOILing. I could just look at that and say, okay, x squared plus 2 times x times 5, which would be 10x, plus 5 squared would equal 25. Looking at another example, let's say I do x minus 6 squared. If I was just to do the shortcut, if I made my a value x and my b value 6, instead of going through all the FOILing and expanding this, I could just say, okay, this all the way factored out would be x squared minus 2 times x times 6 plus 6 squared, which is going to simplify to give me. And when I multiply all this out, this is going to simplify to give me x squared minus 12x plus 36. So again, I think that it's good to show these formulas. They're not super necessary in the sense that as long as you understand if you saw something like x minus 6 squared, you have to just expand it and do like x minus 6 times x minus 6 and FOIL, you'd be fine. But if this shortcut makes sense to you, then go ahead and use that. The last, and I think most important kind of shortcut we're going to go over here is factoring a difference of two squares. Now these I think are important because when you see them in standard form, they're going to look weird. So, factoring a difference of two squares, the general rule looks like this. A squared minus b squared equals a plus b times a minus b. An example would look something like this. What is 25x squared minus 49 in factored form? So if I wanted to do this using the AC method, because technically this is in standard form, I would need two numbers that multiply to give me whatever 25 and 49 or negative 49 multiply out to be and add up to give me 0, which is going to be kind of weird to think about. So this is where I think this shortcut comes in handy. I'm going to make my a value, so if this is a squared, I'm going to make my a value the square root of this. The square root of 25 is 5. The square root of x squared is x. So my a value is 5x. My b value is the square root of 49, which is 7. Using this rule in factored form, my answer is going to be 5x plus 7 times 5x minus 7. And that's it. Just to show you why this works, you don't have to write this down, but just to see how this works out, if I wanted to FOIL this to double check that I'm right, 5x times 5x is 25x squared. This would be negative 35x plus 35x minus 49